All right. Here is part two of the spring final. Part two. This one will be going from numbers 11 through 25. Numbers 11 through 25. And we are going to be talking about inverses. So, if you guys forgot on how to find an inverse, it is in the green. So, those are the steps on how to find your inverses. Gotta check to make sure it has an inverse, but all of these do because that's what we're testing you guys on. Gotta change f of x to be y. You're gonna switch your x and y variables, and then you're gonna solve for your new y. And then when you isolate that new y, then basically you just gotta switch it to be f inverse of x. Alright, so if you looked at number 11, first you change it to f of x being y. Then, so I changed the equation to be y. Now I switch the variables to get this, so x equals that. Now I just have to solve for this new y. So I raise both sides to the third power in order to eliminate this cube root and that third power. So then we get x cubed equals y minus 2. Add 2 to both sides. And then we finally isolate the new y. And then the y becomes f inverse of x. So then we get f inverse of x is equal to x cubed plus 2. So that is the inverse, which is A. Number 12. So for number 12, I changed the f to be y right there, and then rewrote that. You switch the x and y variables, so then we get this. Now we have to solve for our new y, so we have to add 2 to both sides to get this. Now, since that has a fifth root, we need to get rid of that in order to solve for y. So now I have to raise both sides to the fifth power. So that means this fifth root and that 5 cancel. So then we get this. And lastly, we just add by 1 to both sides and change the y to f inverse, and we get x plus 2 raised to the fifth plus 1, which is C. 13. Alright, so same process. So changed f of x to become y. Or sorry, in this case g of x. Change g of x to become y. I switch my x and y to get this line. Now we need to isolate for the new y, so I'm going to add 3 to both sides to get this. Now, what I'm going to do is I'm going to put this over 1 to make it a fraction, and I don't like how my variable y is in the denominator of that one, so what I'm going to do is I'm going to flip both sides. So if I flip, So back to this. If I flip this side, so that's y plus 2 over 4, that means I must flip that side. So that side's going to be 1 over x plus 3. And now just solve for y, isolate y still. So I'm going to multiply both sides by 4. So 4 times that, you just multiply it to the numerator. So 4 over x plus 3 equals y plus 2. Subtract 2 to both sides, and we get this. Finally isolating y, and then the y becomes f inverse. So then we get 4 over x plus 3 minus 2 if it's our inverse. So that is C. 14. Same process, changing my hn to be y. Now I'm switching my y and my n variables. So I see here that I did not do that right away. Oh, why did I do it later? Okay. Anyways, so initially you should have just switched these automatically, which I did later for some strange reason, but I added 3 to both sides. And then from here, that's when I decided to switch. I suggest you always switch first. I don't know why I did that there. So anyways, switch the variables and add by 3, and you should get to this point. Now, remember we have to solve for our y. So I don't like how the y is in the denominator, which means I need to get rid of that. So I put this over 1 to get this. And now I flipped both of them. So I got y minus 1 over 2 and then 1 over n plus 3. Now we just need to isolate this. So I'm going to multiply both sides by 2 so that these cancel. So then 2 times that is just 2 to the numerator, so 2 over n plus 3 equals y minus 1. Add 1 to both sides to get this. And then the y becomes f inverse of x, so then we just get 2 over n plus 3 plus 1, which is b. 15. So remember, change this to be y first to this. And now we switch our x and y variables like so. Now we just solve for isolate and solve for y. So add 1 to both sides. Now you need to get rid of that third power, so cube root both sides, and you get this. And then subtract both sides by 1, and then we get this. And then change the y to be f inverse, so then cube root of x plus 1 minus 1 is the inverse. So we get d. Alright, so from 16 to 20, these are all graphs, but it's pretty much the same thing. You just gotta find what the inverse of this is and then go from there. So 16, I changed g of x to be y. I switched my variables, so this is x and this is y now. Now we just isolate for this new y, so add 2 to both sides. You're here. Now I need to get rid of this fifth root, so I have to raise both sides to the fifth power. Those cancel. So then we get this right here. So all we have to do after that is just add 1 to both sides, and we get the inverse, which is x plus 2 to the fifth plus 1. And which one is that? And that is b. 17. Alright, so change the g of x to be y. Switch x and y variables, so this is x now and this is y. Now we just solve for a y, so we add 1 to both sides, so we get this. I don't like how the y is in the denominator, so I'm going to put x plus 1 over 1. Same thing. And then I flip both of them. So now negative y plus 1 is over 3, but then on the other side, it's 1 over x plus 1. Multiplied both sides by 3 so that I can get rid of that denominator of 3. And then subtracted 1 to both sides. Still trying to isolate y, so we get this. There's still a negative, so I'm going to multiply both sides by negative 1. Now, this side will just be a positive y, which is good, but then to distribute this, you gotta distribute it to both terms. So negative 1 times 3 gives you negative 3, and negative 1 times negative 1 gave you the positive 1. So y is finally isolated, so change the y to be f inverse. So we're looking for the equation that's negative 3 over x plus 1 plus 1, and the only one that is a. Wait, is there 2 equations like that? Let me check just to make sure. 17. Yeah, is A. Alright, moving on. 18. So, there's our equation. So change f of x to be y. Next step, switch your x and y variables. We get this. Now we're isolating y, so we gotta add 2 to both sides. Gotta get rid of that third power, so cube root both sides, and we get this. And then we add 2, and here's our inverse right there. And change y to be f inverse, and we get cube root of x plus 2 plus 2, which is c. 19. Alright, so change the g of x to be y. Switch your y and x variables, so this is x now, and this is y now. So now isolate y, so add 1 to both sides, so we get this. Remember, y in the variable is not ideal, so I put x plus 1 over 1. And now I'm going to flip both sides. So y minus 1 over negative 1, and then 1 over x plus 1. I don't like this denominator of negative 1, so I'm going to multiply top and bottom. I'm going to multiply both sides by negative 1, so these are going to cancel. So I get y minus 1, and on the other side it's negative 1 over x plus 1. Add 1 to both sides, and we get this, which is finally y isolated, so that's the inverse. Negative 1 over x plus 1 plus 1, which is d. And lastly, 20. So for 20, change g of x to be y, so we got y right there. Switch your x and y variables, so this now is x, this is y now. Add 2 to both sides, we get this. Again, don't like that variable in the denominator, so I'm going to put x plus 2 over 1 as a fraction, and now I'm going to flip both sides, so now this is y plus 3 over negative 4, 1 over x plus 2. Trying to get rid of that denominator, so multiply both sides by negative 4, because these will cancel. So then y plus 3 over negative 4 over x plus 2, and then all we have to do is subtract 3, and there's our inverse, which is letter B. Alright, state if they are inverses. So when you guys state if they're inverses, or how you know is if you do the function composition, which means you plug in one function into the other, and then if it comes out to be a variable, then they are inverses of each other. So for 21, I just plugged in g of n into f of n, so remember you plug in this whole thing into that n. So 1 over n minus 2, because right, we plugged in 1 over n minus 2 in for n, plus 2. This, you guys, 1 over 1 out of n minus 2, it's pretty much this one right there, because there's a reciprocal, so it's 1 times n minus 2 over 1, which is just n minus 2. So this is n minus 2 plus 2, and these cancel, so all we're left with is n. So that way gave us n. Now we have to check the other way. So g of f of n means you plug in all of f of n into the g of n function, which is just plugging into n. So g of f of n is 1 over n plus 2 minus 2. But this 2 and this minus 2 cancel, so we get 1 over n. But then 1 over n is just basically this, which is just n. So both of them are equal to a variable, so that means they're inverses of each other, so it's A. 22, now f of h of n, so that means I plug in all of this into the f of n function, which means you're plugging it into n. But when I did that, as you guys can see, I don't see really anything canceling or anything of that nature. So I can't really see anything off the top of my head, so since you know that this is probably not going to equal to n, they're not going to be inverse of each other, so that one's no. 23. So f of g of n, so that means I'm plugging g of n, so that equation all into that n. So then, as you see, I plugged it in, so I get 2n minus 3 plus 1 minus 1 plus 2 to the 5th power minus 2. But then when you simplify the middle, you just get that. And if you raise that to the 5th, that's obviously not going to equal to n. So since that's not going to equal a variable, that is not going to be inverse of each other, so no. Alright, over here. So f of h of x, so that means I'm plugging in all of h of x into f of x, which means plugging it into x. So cube root of x minus 2 plus 2 raised to the third. These cancel, so then we just get cube root of x to the third. But then cube root and this power of third power cancel, so then we just get x. Great. Now we have to try the other way. So we gotta do h of f of x, which is basically plugging in all of f of x function into the h of x, which is just plugging it into that x. So cube root of x plus 2 to the third minus 2. Well, this and this cancel, right? So then we just get x plus 2 minus 2. These cancel, we'll just use x. So they're both variables, so that means they're both inverses of each other. And lastly, 25. So f of h of x, so I'm plugging in all of h of x into f of x, which is just plugging it into the x. So you're going to get negative 3 minus 2. Now remember, this whole thing, x is this whole thing, which is cube root of negative x minus 3 all over 2 raised to the third. So this cube root and that third cancel, so then we get this. Now, see this negative 2? Well, this 2 and that 2 cancel, so then negative 1 is there, so then distribute the negative 1 to both of those. So the negative 1 times negative x would give you plus x, and negative 1 times negative 3 is plus 3. That negative 3 and that 3 cancel, which just leaves x. So that's good. Now we have to go the other way, right? Now we have to plug in all of f of x into h of x, which is that x right there. So I plugged it in. Now, do you see this negative sign? I distribute it both. I distribute this negative to both of those. So we get 3 plus 2x third minus 3. The 3's cancel. So then we get this. But then the 2's cancel. So then we get cube root of x third. But then this 3 and that cube root cancel. So we just get x. So both of them are x, which means both of them are inverse of each other. So that is part 2. There's still going to be part 3 and part 4.